Good morning, students. Welcome to Ramsidhar's IAS Academy. We at Ramsidhar's IAS Academy have started a new module relating to CSAT on request from students. We'll start our discussion with the most basic topic from mathematics, that is Quant. The chapter is Hcf and LCM. First of all, Hcf stands for highest common factor and LCM stands for least common multiple. In understanding these terms in detail, we first would like to know what is factor and what is a multiple. Yes, students. First, what is a multiple? Multiple is that which is obtained by multiplying a number with an integer. Like, for example, multiples of 5. Multiplying 5 with certain integers like 1, 2, 3, 4 and so on will lead to 5, 10, 15, 20, which are multiples of 5. And then what is a factor? Factors are those which divide a number perfectly. Perfectly here, by perfectly I mean the number will be dividing the number leaving no remainder. For example, factors of 50. 50 is divided by 1, leaving no remainder. Similarly, 2, 5, 10, 25 and 50. All divide 50, leaving no remainder behind. That's the meaning of a factor. So now it's clear what a multiple is and what a factor is. Now moving on to the questions. And first, now LCM. What an LCM is? LCM is the least of the common multiples between any set of integers. Now, for example, let us consider these. 8, 12, 16, 18 and 21. LCM of 12, 16, 18 and 21 means the common multiples of 12, 16, 18 and 21 and the least of them would be called LCM. Now, there are two methods in calculating LCM of a certain set of numbers. The first would be prime factorization, which is a standard one and have been used since a long time. Now, in prime factorization, let us consider these numbers 12, 16, 18 and 21, and I'm sure you are aware how to prime factorize a set of numbers. We'll just consider prime numbers over here and then prime factorize them with respect to these numbers, leading to the LCM, and our LCM is 1008, my friends. So this is one method, and the other method which would save you time is this. Here also it's something like prime factorization. I would just divide 12 into a product of its prime numbers, like 2 power 2 into 3, which is 4 into 3, which is 12, can be written as 2 power 2 into 3, and 16 can be written as 2 power 4, 18 can be written as 2 power 1 into 3 power 2, which is 2 into 9, which is 18, and 21 as 3 power 1 and 7 power 1. And in finding out LCM of these numbers, we will just consider those numbers which are present and their highest powers. And 2 is present here, and the highest power of 2 is 2 power 4, so I have considered 2 power 4. And next, 3. The highest power of 3 is 3 power 2 and not 3 alone, so I have considered 3 power 2. And the highest power of 7, it's only 1 over here. There is no highest power of 7 other than 7 power 1, so I have considered 7, which would multiply to give us the answer, which is our LCM 1008. I think you are sure of how to find out the LCM using the two ways. Which one is apt for you, you can use that, my friends. And next, moving to HCF. HCF can also be found similarly in two ways. One which is long division method, and the other the same prime factorization we have used for LCM. This is the most standard method and I would not like to discuss it, as many of you would be aware. And this one I would discuss because this would save you time. So let's just start finding HCF of 48, 19, 120 and 168. Sorry my friends, here 168 is not available, so I'll just remove it. And even if you are to calculate for 168, that should be easy. Now let us calculate the HCF of 48, 90 and 120. 48 can be written as 2 power 4 into 3, which is 16 into 3, and 90 can be written as 9 into 2 into 5, which is 3 square into 2 into 5, and this is 2 power 4 into 3, and 120 can be written as 8 into 3 into 5, which is 2 power 3 into 3 into 5. I have just written them in terms of the products of their prime numbers. So now let's move to our next step. This is the first step in calculating HCF or LCM. Yeah, we are done with that. Now, finding out the HCF. HCF stands for highest common factor, and the factor here we have 2s, 3s, 5s, and the common factors are 2 and 3 only, and we do not have 5. We have 5 only over here and here, but not over here, so 5 will not be considered. We'll just consider only 2 and 3, and in considering 2 and 3, we'll consider only those which are in common and the lowest powers, like 2 power 4. We don't have 2 power 4 in all of them. Only 2 power 1 is available in all of them, like 2 power 1 is available over here. I mean in 2 power 4 there will also be 2 power 1, and only 2 power 1 over here, and 2 power 3 we have a 2 power 1 over here, so I have considered 2. And 3, there is a single 3 over here. In this 3 power 2 I can find 3 power 1, and in this 3 there is a 3 power 1, so I have considered 3. And this 5, there is a 5 power 1, there is a 5 power 1, but there is no 5 over here, so this doesn't constitute the common factor rule, so I have discarded 5. And then, considering only these two, I'll multiply them to get my HCF, and the highest common factor for 48, 90, and 120 would be 6. And the long division method, this is something like one of the number will be over divisors place and the other number over divisors place. I mean, one would be in the dividends place and the other over divisors place, and we'll move on. I'm not going to discuss it. Okay, here we have another example like HCF of 72 and 90. 72 is written as 18 into 4, which is 3 power 2 into 2 power 3, and 90 is 18 into 5, which is written as 3 power 2 into 5. Now, 5 is common, 5 is present only over here and not here, so I'll discard my 5 over 5. And then 2 power 1 is here, and we have a 2 power 1 common in this, so 2 power 1 will be considered. And then 3 power 2. Here there is a 3 power 2, and there is a 3 power 2. Both are common, and I would just like to multiply it, which would give us the HCF of 72 and 90, which is 18. Now, friends, you are sure you are done with finding out HCF and LCM for various sets of numbers. And one important thing to be noted is HCF of a set of numbers is always less than or equal to the minimum of the numbers. Like HCF here is 6, which is less than or equal to the minimum of these numbers, 48. So HCF is less than this. And LCM is always greater than the maximum of these numbers, greater than or equal to. Here 1008 is the LCM, which is greater than or equal to maximum. Maximum here is 21. This concept would be used for us in solving the questions using just options without touching the pen and paper. So let's move to the questions part. Here, find the smallest numbers which when divided by 8, 6, 10, 12 gives remainder 5 in each case. And we can only expect problems of this sort from HCF and LCM. In problems of this sort, we are obliged to find the LCM, and this question can be divided into two parts. Till here it's a part, and from here to here it's another part. So solving the question till here, we will just find out the LCM for 8, 6, 10, and 12. The LCM for 8, 6, 10, and 12 using the best method, I'll get it 120. And the question is not done yet. We have the second part, gives remainder 5. Whenever it is asked that a particular set of numbers when divided by some other number gives a remainder 5, in that case, add 5 to the LCM obtained. I have added this LCM 5 over here, which gives me the answer 125. And 125 is that least number, the smallest number, which when divided by 8, 6, 10, and 12 gives the remainder 5. So I think you understood the question and problem also, and the solution also. So I'll move on to the next question. The next question. 6 bells rang at an interval of 2, 4, 6, 8, 10, and 12 seconds respectively. The time interval after which all of them ring together is. This is a similar question with respect to with respect to the previous one, but just the terms have been changed. The question will be solved on the similar lines. 6 bells rang at an interval of 2, 4, 6, 8, 10, and 12. We are bound to find the LCM of 2, 4, 6, 8, 10, and 12 over here, which is 120. And the time interval after which all of them ring together is 120 seconds, my friends, because these are synchronous and they ring after 120 seconds. All together ring after 120 seconds, which is 2 minutes. If the options are given in seconds, this would be your answer. If the options are given in minutes, 2 minutes would be your answer. Moving on to the next question. This question is relating to HCF, my friends. I'll read out the question. A battalion has 44 tanks, 66 trucks, 110 jeeps. A colonel wants to arrange them in such a way that each row contains only one type of vehicle and all rows have equal number of vehicles. Find the number of vehicles in each row. In questions of such sort, you are to find the HCF. Like these numbers 42, 66, and 110 are divided into rows containing equal number of vehicles. Dividing here means we are just dividing this into smaller units, and the number of rows will contain vehicles less than or equal to this number. And if you remember the logic, when finding out a number which is less than or equal to the minimum of this number, we call it a HCF, and so here we are bound to find the HCF. So I'll move on to the question. HCF of 44, 66, and 110. What would be the LCM? I have written here 22 directly because this comes through constant practice that 44 would be written as 22 into 2, and 66 would be written as 22 into 3, and 110 would be written as 22 into 5. So 22 is common in all of them, so I have written 22 as the highest common factor of 44, 66, and 110 directly. So you can get to here only through constant practice, or you can just make prime factorization over here and then find out the HCF for these numbers. Yeah, this is our answer. And if the question is somewhat twisted and how many rows can be of tanks, trucks, and one-ton jeeps in such a way arranging 22 vehicles in each row. In that case, if the question is asked what is the number of tanks, then the number of tanks would be 2, each having 22 tanks, and the number of trucks would be 3, each having 22 trucks in 3 rows, and the number of jeeps would be 5, like 22 in 5 rows of jeeps. Yeah, this is the answer for tanks. 2 tanks in a row, 3 rows of trucks, and 5 rows of jeeps. If the question is twisted and asked, but the question here is how many number of vehicles will be in each row? It's 22 vehicles, my friends. Yep, we are done with solving our problems relating to HCF and LCM. And the main reason for us to select HCF and LCM for the first day's topic is that HCF and LCM will lead you to solutions in chapters like speed, time and distance, time and work, and pipes and cisterns, and many other such topics. We'll discuss it then and there itself. Okay, friends, thank you.